So we will continue our discussion on probability rules. So we are actually in week 5 now. So this lesson is supposed to be week 5, but since we already done with week 3, from week 1 to 4 topics, we already covered it, and you have already learned most of the topics in those weeks. Then we'll just discuss now topics for week 5. And then later, when we have time, we will solve some probability problems. So we'll just practice solving probability problems and counting problems. Okay. So what are the rules of probability? So there are many, of course, there are many rules, no? Just like rules of how to compute derivative, no, of a sum, of a product, of a ratio, and also some integration rules. There are also some rules of probability that you can use to manipulate probabilities, okay, or derive some expressions. But of course, later on, this will become natural for us to apply. But these rules are, before we can do some manipulation, we must make sure that these rules are valid. So this is the topic of our discussion for today. The rules of probability. So we already discussed that. You can always use these axioms, of course. And then we have the third axiom is actually the rule for computing probability if we are going to compute probability of a union of several events. Okay. And this is what we call the additive rule. But this rule is only applicable if you have disjoint events or mutually exclusive events. Means that if you are going to get the intersection of these two events, you get a null set. Okay, and then of course we have proven this rule. Probability of a complement of that event is just equal to 1 minus probability of the event. Okay? And of course the probability of the null event, event in set here is used this synonymously. Okay, probability of a null event is 0, and you can always derive that. Okay. Okay, so for example, if you're going to compute for the probability that given this table, you have probability here. Okay. For example, if you're going to participate in a lottery 649, the probability of not winning is actually almost half, so 43%. And probability of 1 winning is 0.41, and 2 winning is 0.12, and 2 plus bonus, you get 0.01. And if you actually compute the probability of winning, you have 0.00000000715 probability of winning a 649. So that's how small the probability of winning the jackpot in a 649 lotto. Very, very small. Now, what is the event now that no money is won? So no money is won if you have 0, 1, and 2 winning. It means that you guess one of the numbers correctly, and you also guess 2 of the numbers correct. So you don't win any prize for that. Okay, so what's the probability? So you know that these are mutually exclusive events. Okay, so you have 0, union, 1, and 2. And since these are mutually exclusive events, you can just compute the probability of each and then sum in them. So the probability of no winning, or the event, the probability of the event that no money is won, is actually very high, 0.96. So that is the unfortunate truth about playing the lottery. You will not win any money, 96%. Would you still participate in lottery knowing this probability?
Dili na, sir. Ay, dili.
Really na.
I don't do lottery po, sir.
Pero nakatry na kayo ng lottery?
Wala po, sir.
Yes.
Wala ko yung plan. And kanina nakita na ko niya siya, which is
very small,
advantage. No? Yes.
Yeah. Imagine that Of course, people participate in lottery in the hope winning the jackpot. No, that's there. Of course, the jackpot prize is very alluring. And then you start to imagine things that you will buy, things that you can accomplish if you win the jackpot prize. But if you're going to think it really hard, your chance of winning is actually very small, or winning any prize for that matter is actually very small. So you have to make a sort of compromise or a trade-off between the prize, the jackpot prize, probability that you will get the prize, and of course the probability that you will not win any money, but of course you lose money because it's not free to participate in the lottery. You have to pay around 10 pesos or even 30 pesos to participate. And that is actually very unfortunate because people are losing money, by participating in the lottery every time, and they lose money. Of course, some people are lucky because they win the lottery, but that's not the story. That's not the main thing. And this lottery is actually sponsored by it's a state run lotteries. You can just imagine how much money PCSO is collecting from all those unfortunate people who gamble in the lot. Of course, they use that money to help us well with other. So it's actually a big win for the government, if they run this type of lot. Okay, let's continue. So what's the probability now that money is won? It's just computing the complement. So what's the complement on no money is won? Complement is, of course, money is won, and that is 0.03. It's just subtracting 1 minus 0.9690. You can also calculate it by adding the probabilities here from 2 plus bonus until winning. But it's easier. Some problems are easier to solve if you just compute the complement and then subtract it from 1. If it's easier to compute the probability of the complement event, then use the above equation for probability of the event. This can be useful actually later if we are going to deal with infinite outcomes, infinite number of outcomes. So you cannot add them because you will not reach a point wherein you stop adding because there are infinite events. So the easiest way is just to subtract it. Okay, so let's have a example. This is a famous birthday problem. Maybe you have already encountered this problem, but let's try to analyze this type of problem. This is the birthday problem. So in a room of n unrelated individuals, so they go to they are in a meeting or a party. What is the probability that at least two have the same birthday? So maybe you can think of it as a you invite people on an event, 10 of them, and you want to compute what's the probability that at least two have the same birthday. So you found someone, or you found two people who have the same birthday as a probability of that. So you have to first define some event, the event that at least two have the same birthday. And then of course the complement here is that no pair of individuals have the same birthday. And this is actually a good example of computing the complement. First the complement and then just subtracting because it's easier than to compute for probability of at least two, at least three, at least four, or until the probability that all of them has the same birthday. We just need to compute the probability that no pair of individuals have the same birthday because that's the complement of at least two. Okay. So the total number of ways of assigning the n individual birthdays is 365 to n because there are 365 days in a year, right? So how many ways you can assign birthdays? So 365 raised to n, right? That's the sample space. So later, that's what we are going to use as the denominator. Okay. And then let's count the number of individuals, the number of ways we can assign birthdays such that no two individuals have the same birthday. So how do we do that? Of course, we will just use this formula, 365 choose n times n factorial. Okay, so it means that we are going to select, so the way to solve this is we are going to select 365 for n, since there are n individuals, going to select n dates from 365, and that will make sure that none of the n are the same because you're selecting it. They are selecting distinct n dates from n days or dates from 365. Okay, so once you select that distinct n, you're going to assign it to n people. So how many ways you can assign n dates to n people? That is n factorial. So that's why number of ways you can assign n distinct birthdays is actually 365 choose n times n factorial. Okay, and of course the probability is 365 choose n times n factorial over 365n. And what is our, that's the complement or no birthday. So therefore, probability that at least two of them have the same birthday is 1 minus the probability of the complement, which is 1 minus 365n over 365n. So if you're going to expand that, you will get this. This is actually the same. No? If you're going to expand this part or to solve this part. Okay. No? The idea is just first you assign one date, which is 365 over 365. And then after you assign that one date, you will no longer use that to assign. So there are 364. And then after that, you will not assign the 2 because it's already been assigned to 363, and so on and so forth until you reach 365 minus n plus 1. That's actually the idea. Okay? You get the idea? Okay. And then that's 1 minus this quantity. And then you get, of course, the probability of E. Okay, sir. Okay. Let's try to compute some probabilities. No, if there are, let us say, if there are like 10 individuals, what's the probability that of the 10 individuals, at least 2 have the same birthday? Or what's the probability that if there are 20 individuals, there are at least 2 who have the same birthdays? Okay. So 2 people have the same birthday in a room, we compute. So how about if we substitute it for a concrete value of n? So 10.169, well, the probability is a bit small. Kung 20 naman, the probability is a bit close to 4, and then close. Okay, so we found here a sort of a, that's probability, no? So if you invite 23 people, there is a 50% chance that at least 2 of them have the same birthdays. Yes. No? So it's a bit, how you say, it's a bit surprising. But probability have shown us that there is it's not surprising anymore that in a group in a group of 22 people, in a gathering of 23 people, at least 2 of them have the same birthday 50% of the time. If you can increase that further to 40, the probability gets closer to 1. The ability gets higher. Yeah, you can make that gamble in a party. If there are around 40 individuals, you can say, I will bet you that we can find at least 2 people here having the same birthday. Yes, you can make money. Okay, let's have an example. Saskatoon and Moncton are two other cities competing for the World University Games. How so many others? The organizers are narrowing the competition to final five cities. There is a 20% chance that Saskatoon will be amongst the final five. There is a 50% chance that Moncton will be amongst the final five, and an 8% chance that both Saskatoon and Moncton will be among the final five. What is the probability that Saskatoon or Moncton will be amongst the final five? So this is actually we can solve this by direct application of the additive rule. If you're going to define the event that Saskatoon will be among the final five and assign a probability of 20%. So for example, that's the event A, and the probability is 0.2, and there's a version of the mountain, and we can denote as the event A, and the probability is 0.35. And then I imagine just that what's Saskatoon, and I remember keyword N. So that's 0.80, 0.08. So what's the probability that Saskatoon or Moncton or? So you just add and subtract. So 0.2 plus 0.35, 0.55, right? Minus 0.08. It's 0.47. Another bridge hand is 13 cards choosing from a deck of 52 cards. How many bridge hands are possible? Just 52 choose 13. Wow, that's a lot. This is like billion. 635 billion 013,559 and 600. Can you read it the same? Aldwin? This value?
Sir, ay,
Can you read this value?
yes po, sir. It's 635 billion, 13,559,600.
That will be the amount of money we will have in our bank account.
One, sir.
What is the probability that the hand contains exactly 5 spades? What's the probability that the hand contains exactly 5 hearts? The probability that the hand contains exactly 5 spades and 5 hearts. And what is the probability that the hand contains exactly 5 spades and 5? So how do we compute the probability that there is exactly 5 spades? Remember that there are 13, right? 13 cards. So we need to count. This is just an application of the counting principle. If there are 13 cards, how many ways we can get 13 cards wherein there are exactly 5 spades? It means that's also 8 spades. So in order to count, we of course set the number of spades already, right? Which is 5, which is for the first 5 position, there are already 5 spades, so we do not fill that position. Okay. So we're left is 8. So how many ways we can get 8 non-spades? So if there are 52 cards, 5 spades. First, we need to select which of the spades will go to our bridge hand. So how many spades are there in a card of 52 deck?
13.
13. And then we select spades, so we have 5. Okay. Now we multiply this because we need 13 cards. So that would be 8 here. But since these are all non-spades, we need to subtract 13 from 52. So we have 39. Okay. So that is the total number of bridge hands which contains exactly 5 spades. Okay. How about the probability that the hand contains exactly 5 hearts? Same thing, right? What's the probability that the hands contain exactly 5 spades and 5 hearts? So that's just 13, 5 times 13, 5, and 26. Choose 3. Okay. Because this one is for the spades, this one's for the hearts, and we need to subtract, okay, the 26 from 52, so that's 26. And then since we have a bridge hand which consists of 13 cards, and there are already 5 hearts and 5 spades, so the remaining number of cards that we want to fill is only 3 now. So that's 26, choose 3. Okay. So what's the probability that the hand contains exactly 5 spades or hearts? So this is just application of the additive rule, which is just this one plus this one minus this one. Okay, so this is just the solution that we did, 13.5, 39.8. Because we are looking for probability, these are not yet probability, of course. But if you divide that by 52, choose 13, you can get the probability. Same thing here. Probability of 5 hearts, no? 2 over 13. Here as well, 13, 13. This is the same thing we did. And of course, the final probability is 0.24. So there is a 24.26 chance that a bridge hand will contain at least one 5-card bridge. Now, what's the additive form for more than 2 events? Ala, medyo mahirapan na tayo. So the idea is, of course, just to use that theory. The union of B, C is equal to A, B, C minus intersection minus plus the intersection of the 3 events. Alam niyo na yan. So, hindi na natin. Okay, so the idea is just, you want to compute the probability of this event. First, you need to compute the probability of A, then compute the probability of B, then compute the probability of C. However, if you try to do that, you will actually add twice these intersections. Now, for example, if you compute the probability of A and B, you're going to add this part twice. That's why you need to subtract it, subtract, pack. Same here, subtract, pack. And same here, subtract, pack. But the problem again is that you over subtract the intersection of the 3 events. So that's why you add them back. So that's why you have this formula. I want you to solve this problem.
95% po, sir.
The correct answer is tama. Then we have also the additive rule for more than 2 events na kung atin naman siyang i-include more than 3. No? Kanina yung more than 2, 3. How about ngayon kung meron na tayong n events? So it's very easy. I-alternate nyo lang. So first, plus, minus, tag-dalawa-dalawa, plus, tag-tatlo-tatlo, minus, tag-apat-apat, plus, tag-lima-lima, minus, tag-anim-anim, and so on and so forth. And the general is negative 1, n plus 1. Okay, so, depende, hindi pala general. Yung end. Okay, so if n is, let us say 10, so dapat mag-end kayo ng 10 plus 1, which is 11, and minus 1 raised to 11 is negative. So, negative. Pero kung add naman, so let us say 11, yan ay magiging 12, so magiging positive. So, yan lang yung pattern na. Para hindi nyo makalimutan, kahit dito pa lang, tingnan nyo na kung even siya, negative siya. Kung add siya, positive siya, ang n. Suppose that we have a family of n persons. At Christmas, they have decided to put their names in a hat. May n person, no? Ilagay nila yung, sulat sila ng name nila. Siguro sa isang papel. Then they yung papel nilagay nila sa hat. Okay? So, siguro nila shake. And then each person will randomly pick a name. This will be the only person for which they will buy a present. So kukunin nila so parang yung sa high school pa tayo or elementary, mabunot-bunot kung sino yung maano mo, sino yung mabigyan mo ng gift. Question, what is the probability that at least one person pick his or her name? Ano kaya probability na makuha niya is yung name? Di ba nangyayari yan, di ba? Sa buhay natin. And how does this probability change as the size of the family n increases to infinity? Sige, Aldwin. Try to solve it first kung meron lang, let us say, 20 na tao na mag-participate. What's the probability that at least one person picks his or her own name? And then try to generalize it for n, and then compute for several n. So the very important thing first is that you understand the problem. I think it's not that difficult to understand it. So we can solve this using, of course, the additive rule. So the event that a person I picks his own name, we will to calculate that. Okay, so that's probability of AI, E2. So for example, there are 20 people, no? What's the probability that, let us say, ang isa sa invited doon is si Kunahap, si Aldwin. Okay, what's the probability that Aldwin will pick his own name? Or what's the probability that Kyla will pick her own name? Parang ganyan. And of course, we are going to subtract that by the probability that two of them will pick their name, so on and so forth. Okay. Okay. So, how many ways can you assign names to n people? Of course, there are n factorial because given a set of names, let's say 20 names, you can assign that to 20 people in n factorial ways or 20 factorial ways. Okay. Now, to calculate that probability that each of that person will get, or at least one of the person will get his name, we need to calculate the probability that Kunap will get his name, probability that Kayla takes his name, that Dalian takes his name, and so forth. And that is at least one. Okay? At least one person. Now, if you have at least one person, you can now calculate the probability that no one will get it. Okay? So yun yung ginamit mo kanina, Aldrin, na complement. But it's actually a bit difficult to compute that compared to just computing them directly. So the number of ways you can assign person I his own name and arbitrarily assign names to the remaining n minus 1 person is n minus 1 factorial, because you make sure that you assign that name to that one person and arbitrarily assign it to everyone else. Therefore, the probability that you correctly assign it to A, regardless, this is regardless of whether the other people got his name or did not get his name. It doesn't matter because that's not a probability. We are only concerned with the probability that you get your name. For example, probability that Kunahap gets his name. Something like that. Now, if we compute that for all people, you would actually get 1 over n. So there is a 1 over n chance, which is very intuitive naman, that person will get his own name. Now, what's the number of ways that you can assign person I and person J their own name and arbitrarily assign names? So first you assign 1, second you assign, that's actually another one, and then you can arbitrarily assign n minus 2 names because the first 2 names have already been assigned. So there is n minus 2 factorial, and the probability is 1 over n minus 1 factorial. And that is for all pair. Okay? Ito naman is for all individual. So this means that exactly Aldwin and Kayla got their names. Yan ang ibig sabihin niya. So if we compute that for all pairs, then we compute that for all pair of people. And we have the probability of 1 over n minus 1. Correct? Okay, now if you're going to sum that, you get 1 over 2 factorial. And then so and so forth, you get 1 over 2 factorial, 1 over 2 factorial, until you get 1 minus n factorial. But since you're going to apply the additive rule, then you will end up with 1 minus 1 over 2 factorial. Parang ganito, 1 minus 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial plus 1 over 5. Yeah? Now you do it. So if you're going to continue that, you get this pattern. And if you increase n, actually, you get this series. And this series is actually equal to 1 minus e negative 1. Because the expansion of the, are you familiar with the Taylor expansion, no? Familiar ba kayo yan? Yung Taylor? Yes. So yan yung Taylor expansion ng e to the x. 1 plus x plus something like that. And then, if you substitute it by negative 1, so e negative 1, negative 1, what happens is that it will become 1 minus 1 plus 1 over 2 factorial plus minus 1 over 3 factorial So you will basically end up with 1 over 2 factorial minus 3 factorial plus 1 over 4 factorial and so on, minus so and so forth. Now, so that this will become this one, you just need to subtract it by 1. So yan ay magiging 1 minus, then this will become plus, this will become minus, and this will become plus. Okay, so that's actually the expansion. So let us try to look at how this probability change for various number of n and for if we allow n to increase without limit, so up to infinity. If there are 10 people, what's the probability that at least one person pick his name? What's the probability? So that's just 1 minus 5 people. Let us say 5 people. So that's 1 minus 1/2 plus 1/6 plus minus 24 plus 1 over 24, 120. So anong result natin dyan? 0.63. It is actually a big probability. Okay. Now, if you increase the limit, you know the number E is equivalent to 0.71. So if you try to do that, 1 minus 0.63 to 1. So if you increase it to until infinity, there is always a 63% chance that you will get your own name. Okay, so that's actually quite, I mean, at least one will get their own name. And this actually follows as well. If there are only 2 people, probability is 1/2, you get your own name, right? If there are 3 people, probability is 2/3 or 0.66. So it will not go up, okay, by 63, 21%, okay, because that's already the limit to infinity. So I think that's some exercises that we did using various rules. Sige, discuss natin ang Bayes rule. Okay. Yan si Bayes yan. Ano? Tanda na yan pero patay na yan siya. Isa siyang pastor, reverend. Muna ana ayang suot. Dili na siya ingon nga burag baby. Lampino. Pastor na siya sa unang panahon. And then, na siya yatag na or he proposed a rule which is very, very useful. The probability. And that rule is named after him. And that is actually the Bayes. Okay. So how do we define Bayes rule? I think we can start with conditional probability. So this is just a review. Okay. Aldrin, what is the probability of A condition on B?
E ay probability of
Or N?
and diacer intersection. Ay, tama
Okay.
mo. Over probability of
B. Okay. This is the conditional. How do you compute probability of B given A? It's just probability of AB. Same lang man siya, di ba? B, A, or AB. Ang naglahi lang ang iyang denominator, which is A. So therefore, ang probability of AB is equal to probability of A given B times probability of B. Tama? Yan lang na siyang i-multiply. And also, basically, probability of AB, pwede po siya probability of B given A times probability of A. And the Bayes rule actually is just how do we obtain probability of B given A if we know probability of A given B. Since equal naman na sila, pwede na nato sila i-equate, di ba? Equate din duha. Right? So probability of B, A given B times PV equals, tama? Now, since they are equal, you can actually compute the probability of B given A if you know probability of A given B. Kung i-divide natin na siya by PA. Then we obtain BA. Now, if we want AB, given that we know BA, instead of dividing that by, we can also divide by PB. And this is the Bayes rule. Pareha man ang taas, pero sir, lahi lagi ang ubos. Ano mo? PB lagi niya. Ano man na, taas man kayo na. Well, that's actually from the law of total probability. Okay, yan na yung probability, tama ang taas. Yeah? Baliktad lang yung A at B, pero that's basically the same. Ang kaibahan lang is sa baba. Paano naman yan, sir? Paano naman yan? Ba't iba naman yan? Well, that's what we call the law of total. Saan yan galing yung law of total probability? Okay. Anuin muna natin ang total probability. How do we compute probability of B? Okay, imagine ninyo that our sample set has a partition. So, ano ibig sabihin ng partition? Partition meaning set of events that are disjoint and the union is the sample space. Kuha nyo? Definition. Set of events na disjoint and ang union niya ay ang sample space. So basically, it partitioned the sample space into disjoint sets. So we can represent that as, let us say this. Okay? So let us say this is E1, this is E2, and the whole of this is E3. Okay? So wala ay siya region nga nag-overlap. Pero kung imo po siyang i-union, siya na ang tibuok sample space. Now, how do you compute the probability of kini nga event? Let us say that is B from the partition. It's very simple, right? You just get the intersection of these three. And that is the probability of B. Now, if you start with the intersection, remember that probability of A given B is equal to probability of A, B over B. Kanina binigay ni Aldrin. So therefore, kung kukunin mo pala yan, you just need to multiply it by PB. So this will become probability of B, but you have to make sure that that is probability of E times probability of B given E1. Pwede din actually nasabihin niyo probability of B times probability of E given B. Okay? Wala problema. Pero ano yung sinusunod natin? Okay. Dapat given si B. Okay. Tama itong form natin. Plus probability of E2 times probability of B given E2 plus probability of E3 times probability of B given E3. Now, once you have that, this is now what you call the law of total probability. Okay, so the technique here is just to find a partition of the sample space. Okay, going back to Bayes rule, remember that kailangan natin ng B. Use natin ang B. So hanap tayo ng partition ng ating sample space. Remember that we have A, right? Event A. So ang partition ng A, ang complement ng A ay A complement. Di ba pag i-union natin yan sila, yan yung S, yan sila, diba? So therefore, A and A complement forms a partition of S. So we can actually use this as our partition. So following this formula, that is just probability of A times probability of B given A plus A complement, probability of A complement times probability of B given A complement. And that is exactly this. Ang ginamit lang yan na complement ay slash sa taas. Okay? So that is the law of total probability. Remember that this is the Bayes rule. Ito, of course, ito hindi naman to Bayes rule. It's law of, our law of total probability is just used to expand the PB in terms of A and A complement.